So now we have the general term for a geometric sequence. A sub n equals a sub 1 r to the n minus 1. Now, if r is greater than 1, then you're going to have a growth thing going on here. Your numbers are going to get bigger and bigger, right? We've seen one where r is less than 1 or r is negative, and that's a different thing. But if r is greater than 1, it's going to keep growing. So you might say, well, that looks familiar. Remember when we had exponential functions? An exponential function was f of x equals, you could have some constant and then b to the x, right? So you can see the similarities here. This is an exponential function. This is a geometric function, a geometric sequence, and they are both growth problems. Okay, so if b is greater than 1, you're going to get growth here. So geometric growth, exponential growth, same. Okay. So we have a chart here that shows the population of the US in 2010, and then it estimates from 2011 to 2020. These are estimates of the population. Okay, so how do you know if it's a geometric sequence? Maybe it's arithmetic or some other type of sequence. Well, the way to do that is to check the ratios to see if there's a common ratio. So take two consecutive numbers, 310.9 divided by 308.7, 310.9 divided by 308.7, and you put it in your calculator, and you're going to get approximately, now we're going to round to 3 decimal places, 1.007. Well, that's not enough to establish that it's geometric. Now you have to take two others, and it doesn't have to be the next two, but I did the next two. So I'm going to do 313.0 divided by 310.9. And you put that in your calculator. I already did this previously, but put it in your calculator, and rounding it off to 3 decimal places, again, you get about 1.007. Now that gives us a sneaking suspicion, well, maybe it's geometric. That really isn't enough though. You have to go another time, at least 3 times, to see if it's geometric. So now I'll take the 315.2 and divide it by 313.0. And again, when you put that in your calculator, stop the video, put it in your calculator, you're going to get about 1.007. Now it's not exact, but it's pretty close, okay? So we're thinking that they have a ratio, a common ratio of about 1.007. Okay, so that's enough to say, okay, we think this is geometric. You could try 2 others. Let's try 2 others. I didn't do these before. So 324.2 divided by 321.9. So let's just see if that holds true. So I kind of jumped further down the sequence. So I have my calculator, 324.2 divided by 321.9. Let's just see what it says. Yep, it's about 1.007. Okay, so we're just checking. Any 2 consecutive terms should have that common ratio. Okay, and they do. So now we're going to go to part B. Part B says write the general term. Okay, so the general term is written from this. But we know a sub 1. So the general term is going to be, what was the first one? It was 308.7. The common ratio, we've got that. It's 1.007 to the n minus 1. So that would be the general term for this geometric sequence. Okay, now they want us to project part C. They want us to project the population in millions for the year 2030. Okay, so our years were after 2009. So 2010, oops, that would be the first term. And then what's 2030 going to be? Well, that's going to be the 21st term. Okay, So you've got to count the 10 and then you've got 11, 12, you can count them on your chart there. Okay, so that's going to be, well, up to 20, I guess, and then you'd need 10 more. All right, so the 21st term is going to be 2030. We have to know that because that's what n is. N is 21 then. Okay, so we put it in our formula. We're going to say a sub 21, the 21st term, is going to be 308.7 times 1.007 to the 21 minus 1. Now, I would go ahead and do that little calculation, that subtraction, by hand. Okay, that's not too hard, right? 21 minus 1. But now this, I'm not going to do by hand. I'm going to put that in a calculator. So let me grab my calculator. And you can stop the video and put it in your calculator if you want to follow along while I put it in. So 308.7 times, I'm just going to put times, you could put a parenthesis, but 1.007, and then I have to have my exponent button to the 20th power. And my calculator knows the order of operations. So it looks like I'm getting about 354.9 million. Now I'm going to go one decimal place because that's what they were showing on the chart. So we're going to say in 2030 that we prediction is 354.9 million people. Okay,